Now, in this, you're going to say, well, how did the people with morning sickness that are given thalidomide, how did the right form, was it just pure luck? Yes. Pure luck. Yes.
What do you mean by one active and one inactive?
I haven't got there yet.
Oh, I'm sorry. Okay, I thought your mind.
Okay. So in the other case, there's a drug called L-DOPA, and the other one is D-DOPA. L means left for levitro in Latin, and D is dextro, which means right in Latin. So D-DOPA, the right, is inactive, and L-DOPA is active. So this is really cool. How does this enantiomer work? L-DOPA and D-DOPA. We all know Parkinson's disease, Michael J. Fox, I've talked about it. And people with Parkinson's, have muscle tremors and muscle shakes. Just, uncontrollable rhythmic convulsions or what we would consider twitches. So I talked about this in anatomy last year. So if this is the brain, in this area right here, it's called the substantia nigra. Substantia nigra. And this is towards the midbrain. And here in the frontal cortex is what we call the basal striatum. And these guys are connected by a long highway of nerve cells called neurons. And this pathway is like I-75. It's not like Coleraine Avenue. When you go down Coleraine Avenue, you can get off Coleraine Avenue just about every 30 feet. Get off. All right? But I-75, you have to go miles sometimes to get off. So this is considered a highway. And when normal bodily function is going, dopamine, we all know it's a neurotransmitter, is sent from here to here. When dopamine is sent from here to here with the right amounts, this relaxes. Now this is short man's Parkinson's description here. This is a lot more complicated. I'm just giving you a Cliff Notes version. This relaxes relaxes one's muscles. Okay? No tremoring. If this is damaged in Parkinson's patients, the message gets shut off. There's no message saying to stop the tremoring, and that's where the tremors come from. So L-DOPA is given to stimulate dopamine to go to the basal striatum. But L-DOPA has an enantiomer, and this took a while for them to figure out, called D-DOPA, right dopa, dextrodopa, that when given them, that enantiomer was inactive, Shelby, and it did nothing. So some patients were responding and others weren't. How cool is that? Does this make sense? How the chemistry affects the biology? Yes.
L-DOPA is active, D-DOPA is inactive.
Yes. For Parkinson's. Yes.
Well, this might not be how it works, but why couldn't they just get enough of it so wouldn't they get some of the L-DOPA and some of the D-DOPA?
Well, then if you got all L-DOPA, you might like to.
Yeah. It has to be regulated. Neurotransmitters, and we're going to talk a little bit about that towards the end of the year. There's a docking center that they go into, and if enough build up outside this docking center, bad things can happen.
Or why wouldn't, even in like the right size quantity, why would there be just L-DOPA or just D-DOPA? Why wouldn't it be like some of both? If you said it was just like based on luck, like what it is.
Well, because your body is only going to recognize one of them. It's not a hit or miss thing. Our body is not throwing darts at a dartboard. Our body, when we get into learning about cellular respiration and photosynthesis, we are programmed factories, and we need a certain rhythmic way it works. And so without going into the technical details, because I'm not a neuroscientist, I'm just a humble teacher, all I know is that this has to be done in the correct amounts. If you give it both and hope it works, it still's not going to work. And believe me, we need more than Parkinson's than just giving them L-DOPA anyway. Yes. Xander.
How do you like I know if you draw it, you can obviously see the difference between an enantiomers, but how do you like tell the difference in the real world? Is it a complicated process to figure out the
Like
difference?
to test.
Because like how do you figure out if the drug is L-DOPA or D-DOPA?
Yeah,
How do
it's
they?
pharmaceutical companies and all that.
Have they fixed that?
Oh, yeah.
Okay.
Yeah, but that doesn't mean we
now
just give.
can we give it
Although
out?
we fixed this in the 90s, but this is, there's way more to it than that. It's like saying AIDS with AZT, azidothymidine, to treat AIDS. I mean that may work now just a little bit to relieve some symptoms. It's not a cure, but it was fairly effective in the 90s. There's a lot more to it than this. I'm just giving you one example of how the biology works. Yes.
Wait, so you said L-DOPA contains D-DOPA?
What?
Did you say L-DOPA contains
No.
D-DOPA?
L-DOPA and D-DOPA are two different things.
So then you said when they gave the patients L-DOPA.
Yeah, they can give them L-DOPA, but they didn't know they were giving them L-DOPA. They were giving them D-DOPA because they didn't understand the enantiomers.
Okay. So they thought they were giving them L, but
Yeah, they didn't tell the difference. They're mirror images of each other.
Oh, okay.
Yeah.
That's why it didn't.
Sure. Yeah, Maga.
Is it like when they made it, like they didn't know how to, they made it and it was just like changed by luck? Or like, do you make it the same exact way?
No, it doesn't change by luck. It's just there's two different forms of it. They were giving them one form, thinking they were giving them the other form.
So because D-DOPA
So they were thinking they were
Yes, they were giving them D-DOPA, thinking it was L-DOPA.
and